Welcome to another video. This time I want to look at generating more efficient bytecode that uses the stack in a better way. So this is a function, well, this is just commented out, but it just multiplies two numbers, 2 and 1, and then it adds 4 to the result. When we compile that, first of all, compiling the compiler takes some time, but the generated bytecode is not efficient. It works, but still. So what we do is the main function accepts an argument, the a, and we kind of duplicate that. We push these 8 bytes that make up that integer from offset 0 of the top of the stack. We push those again. And then we push a 2 to the stack and a 1. Then we push the 2 again, skipping the 1, those 8 bytes, to get the 2, push that on top of the stack again, and then push the 1 again. Then push the 2 again, push the 1 again, and then calling the multiply function. That kind of pops these two, that consumes these two numbers and pushes the result to the stack. And then we push a 4, and then we push the result and the 4, and the result and the 4, and we call the plus function. And this works, but it is inefficient. So why are we generating this crazy code where the majority is just pushing and popping values? Well, the reason is that when we have nested expressions in the code, such as this one right here, in the beginning of the compiler pipeline, these get decomposed into simpler expressions. For example, maybe we can even see that. Maybe not. They're decomposed into simpler expressions like create, like here, create a 2, create a 1, call the multiply function with those 2 temporary variables, create a 4, call the plus function. And that makes sense because we want to simplify everything, and this is a very simple, uniform syntax, uniform representation of the program, where we have these expressions, each of these has types, and they're decomposed, and we figure out in which order should we execute operations. But then when converting that to the next compiler stages, we just turn every single of these temporary variables into a new local variable in here. So this is the Waffle representation of the program, which is a well-aligned form of fixed layout expressions. So here we have memory layouts for all the types. And what we do is we have these functions, and this is a representation that allows nesting, but we don't really use that. For example, the multiply function here, it only accepts a single argument in here, because it actually accepts kind of like an aggregate of the two numbers. So first we create the two numbers here, then we create an aggregate of those two numbers, and then we call the multiply function with those two numbers. The interesting part is, in this representation, we could actually nest expressions like we do in here. So we could just say, call this multiply function with an aggregate and put the aggregate directly in there, and even put the numbers directly in there. Because when converting the Waffle to the stack-based bytecode, the ground, we kind of use the stack only for these kind of nested expressions. All these local variables, all these temporary variables, they become actually, like variables that are that have reserved memory on the stack. They are not some temporary thing. So during the entire lifetime of the function, these will keep existing, even though we need this right here only for the multiply function. And that's the reason why we see a push instruction for the 2, we see a push instruction for the 1, and then we see push instructions that kind of construct this aggregate, pushing the 2 again and the 1 again. And then to call this multiply function, we first have to push the arguments, which again pushes the 2 and the 1, and then calls the function. So today I want to look at nesting, okay, making the waffle more tree-like in its shape. I think actually this is one of those cases where the compiler stage itself is fine. I'm converting the previous stage before the waffle, the pudding, to the waffle. That it makes sense to have local variables for all of these and actually create local variables. But I think given a waffle, we now want to optimize that. We want to have basically like a compiler stage that goes from waffle to waffle, more optimized waffle. Yeah, so that's what I'm going to work on today. Which means I'll create a new file, I guess. Oh, hang on, let me first commit some things. Okay, done that. So yeah, next I want some sort of optimized waffle, I guess. Maybe with some sort of optimized function that takes a waffle and, well, returns a new waffle. Because I think it's easier to construct a new waffle than kind of modifying the existing one, trying to figure things out, how to change stuff. So yeah, let's maybe look at how we compile to the waffle and kind of adjust. I copy that general structure and then adjust that. Yeah, okay, so this is not... Yeah, this makes sense. Yeah, importing the main file. Optimizing the waffle. Yeah, with memory layouting stuff, we don't need that. The waffle already has fixed memory layouts. Yeah, this is the interesting part. But we don't want pesto. Oh, pesto is the previous one, right? And convert that to waffle, but instead we want a waffle expression. Okay, and convert that to a waffle, I guess. Let me comment that out right now. Yeah. And okay, so this converts some body, which we don't. We do have that, yeah. And this, let's call this optimize. Let's remove pesto from the picture. And also remove the optimize function up here. I think I'll just update the one below here. So we want to have a waffle and optimize that. So the waffle contains functions. And I think we can optimize all those functions individually. So for every function, we just say funs.put the key and the value to optimize. Do we need that? We don't need functions to know other functions. That can be like an independent thing. Fun is fine as a name, but it is a waffle fun. Yeah, I think a fun builder still makes sense. Fun has params maybe with size and layout. Okay, and we want to minimize the amount of local variables that we create. Oh, it only contains a body. Okay, yeah, so this is really just a body. Fun.body.param.size probably. stuff like that. Let's get that out of there. It only contains these locals and returns. Hang on. Oh, bodies don't have parameters in here. Really? That is actually kind of cool. Locals. And the bodies don't have parameters. Oh, I see. So I think 0 is just implicitly, the the main, the argument to the function. That's cool. So let's do fun.get. I hope you can do that. Get 0. Oh, I see. Fun.body.get 0 probably. Maybe not. Oh, get on a waffle fun with a waffle ID. Okay, that's what we want. That's exactly what we want. So we want to get the ID on the fun. Okay, ID 0, that is the parameter. And then for our own parameter, yeah, we don't need a mapping, I believe. No. We just want to inline things, rather than. I basically want to put the this aggregate directly in here. I think it makes sense to have two optimization passes probably. One where we try to put most of these in here, and then another one where we kind of remove ones that are no longer used. Yeah. So okay, let's do that. So we have a waffle. Yeah, we don't need that actually. Nope. Just wondering, like, where do we... Oh, the Waffle fun builder already creates that internally, I guess. And then we optimize the function body. It doesn't need mapping, it doesn't need pesto, it only needs well, the original function to get expressions, and then a function builder. Yeah, so this only needs the original function and a function builder, nothing of this. What we do is we go over each of these expressions and we create a local variable. Okay, yeah. But we try to optimize the expression. Perfect. Yeah, we don't have a mapping, so we'll just do that. Okay, so this optimize call is probably the most interesting, because that's this giant function. Actually, this is, I'm going to call this, I mean, optimize is fine for now. Okay, so param is unreachable. An integer should just become an integer. That is fine. A string is just an aggregate without local variables. That's perfect. That's exactly what we want. A struct, however, I mean, a struct is not even a thing. I think I'm going to copy the... We have some, yeah, Waffle to ground. We have a giant switch in there at some point. Somewhere. Yeah. These are the actual expressions that we need to handle. Param, padding, local, switch, and so on and so forth. Let me think about this a bit. Okay, so we have a waffle expression actually that we want to optimize. And the weird thing is, like, if this is a padding, then there's like that is perfect. There's nothing that we need to do. If this is a byte, there's nothing that we need to do. If this is an integer, there's nothing that we need to do. For most of these, they just map to themselves, I believe. I call indirect functions malloc free load store. Yeah, right here is where the old one begins. So I think I'll just copy that, kind of create some sort of identity mapping, you know? Yeah, so a padding just becomes a waffle padding of the amount. A byte just becomes a waffle byte. An int becomes a waffle int. A local, this is interesting. There's gonna be to do, because this is where we actually want to see, can we inline that local? A field is also interesting because I think we want to optimize the fields inside. So basically we want to return a waffle aggregate of some fields. Parts that we create beforehand. That's going to be a list of waffle expressions. And what we do is we do every part of the aggregate, we do parts dot push part dot optimize using the fun and the fun builder and the builder. Yeah, perfect. Okay, so my plan is first create an identity mapping and then look at where I can optimize stuff. For member, this will just be waffle member. Probably has an off, I guess. How does a waffle member work? Waffle member has off, which is a waffle expression at an offset. So off will be member.off.optimize. And the offset will just be the member offset. Okay, then a switch. A switch will just become a switch. So this will be a waffle switch with a byte. That would be the switch byte optimize fun builder, and then cases, which will be waffle bodies. Yeah, and for every body in the switch bodies, we do cases dot push body dot optimize using the function, I guess, and also the fun builder. Then having a call, that's interesting. That will be a waffle call how do those work? They have a function, which is a string, sure. So let's just call that function. And they have arguments, well, okay. Oh, which is a single waffle expression. That's nice. So we can just do call.args.optimize using the fun builder, and the builder. Amazing. Then call indirect. It's going to result in a waffle call indirect of the function pointer optimized and the args optimized. Beautiful. Okay, a function builder, a function pointer will just be a function pointer. Adding stuff will just be waffle add of args.optimize using the fun builder and the builder. With different names like that. Yeah, this same thing basically. Just waffle compare 0. Of that. Beautiful. Yeah, malloc will just be a waffle malloc of the size optimized. This is a bit tedious, to be honest. Well, free of some free, and the free will contain the pointer. Maybe. I don't actually know. Oh, I see. Pointer and size. Yeah. This will be just a waffle load of the pointer. Same with the store. Store actually has a pointer and a waffle as separate things. Pointer and value. Yeah, crash will just be a waffle crash. Optimized arguments. Okay. Cool. Let's see if this compiles. Case is not in scope. Yeah, we want to switch on the expression kind. Yeah. And we also want to actually call that, although let's first check that this, okay, this does compile. Yeah, so we have the waffle optimizing. And that's just going to be the waffle, is going to be waffle.optimized. Okay, yeah. Waffle.optimize is not a thing. Oh, because we don't import that. Makes sense. So pesto to waffle, then we have the waffle, and then we have an optimize waffle. Oh yeah, we need the waffle body builder apparently, for some reason. Let's see. Fun builder body. For every ID, we do something. Body to optimize. Oh, this is a pesto body. I think I should look for pesto in this entire file. Okay. No other currents. That's promising. Yeah, local is not a field on waffle body. Yeah, it's locals. Yeah, waffle aggregate. Actually needs a slice. Sure, I can work with that. Oh, okay, so waffle member needs more stuff. Probably the size and alignment. Yeah. Okay. So that would just be the expression size and alignment. Okay, bodies is not a thing, instead it has cases. Yeah, well, why do we call them body? It's called a case. Okay. Yeah, that's push, not put. Oh yeah, list and slice. Sure. Sure. This call doesn't work. Waffle call. Oh yeah, probably needs the size and alignment. Same thing, probably. Actually has two. That is interesting. Yeah, no, that's not waffle and hang on, waffle. I see. Does it maybe not make sense to use the waffle constructors? Maybe. Yeah, maybe I should just, because we don't need any of these, sanity checks, and also the size and alignment, we already have that. And we only need to map the kind, basically. Sure. let's say we build a new waffle expression kind of manually. Where we just say this is unreachable, this is a waffle expression kind of padding of some amount. This is a waffle expression kind dot byte. Does that make sense? Hang on, let's stop and reflect for a minute. I think it does, yeah. Let's just turn it into a local. Now look at that. That becomes easier. Yeah. I see. Oh yeah, that's probably the case for other stuff as well. Here as well. Ugh. Okay. True. This is just called arg because it's a single number. So then this entire thing just returns a waffle expression with the kind, size being the original size, and alignment being the original alignment. We did that, okay. Yeah, so optimizing, and this is the optimized waffle, which looks exactly the same as the original waffle. Fair enough. But now we can actually see, well, let's say we have this case right here. We have a call with some arguments, and those are a local thing. We can just check, is the local funder get the local. Actually, you know what, let's add a commit for that. Let's say this is identity again, add as optimizing. Okay, and now we'll change that. So for the local variable, we actually want to get the corresponding function expression from the fun builder, I mean, sure. And then if that is an aggregate, okay, so if we call something and the argument is just another call, then we don't want to inline that, because the order in which calls happen is important, and like also assume this is actually not just a 2, but this is the result of calling something. We don't just want to put that call in here, because if this is used multiple times, we actually only want to call that called function a single time, store the result in a local variable, and then use the result multiple times. So actually, we need some way of checking, is that other expression there, is that pure, I guess, is that, has that side effects, has side effects, and if it doesn't have side effects, only then will we return, hang on, now we can check, does that have side effects? Then, only then we will return a reference to the local, otherwise we will just return that expression directly. Yes, something like that. Yeah, has side effects. We need to add that. So does a waffle expression has a side effect? I think we can actually, we don't need anything else to determine that. If that is a param, that is, maybe it has side effects is weird, because parameters should also not be inlined. So maybe I'm just gonna call it should inline. Parameters, no. Padding, yeah, definitely. Bytes, yeah. Ints, definitely. Other locals, no, because at that point we have, we assume that this expression is already, you know, optimized inlined as much as possible. So if that still is a local, then that referenced expression is actually not not inlineable. I mean, yeah, okay, actually we do want to inline locals by not having an extra indirection there, another local. Okay, yeah, aggregates. Oh, that's interesting. That depends on whether the parts here, if they should be inlined. So if any part should not be inlined, then we return false. Otherwise, we return true. Yeah, for members, it's a member of should inline. For the switch. Ooh, that is interesting. For the switch, we do have to check. Let's just do a false for now. Also add it to do. Yeah, for a call, calls should not be inlined. Period. Because the call function may have side effects and so on, and we don't want to track that here. Yeah, an indirect call, also not inline. A function pointer, yeah, that can be inlined. Oh yeah, the add depends on whether the arguments should be inlined. Here is arg dot should inline singular. This is arg, so should inline. Same here. Yeah, manarch. Ooh, I'm not sure. Let's say no. Manarch and free. We can always, yeah, relax that later on. Loading something. Let's not do that. Storing something. We treat memory access as something, you know, something weird, something. Yeah. Okay. Nice. So getting a Waffle ID from a Waffle funder is not a thing apparently. Well, that's unfortunate. Can we just do build out or get? Maybe. No, also not a thing. Oh, okay, hang on. Okay. We have locals. That is this part right here. Alright, we can't get. The idea that is weird, you know. And maybe that's what we are constructing Waffle expressions by hand here, not using the constructors. Let's maybe also not use the builder, but instead just create those expressions directly. Yeah, let's do that. So a Waffle fun, if I remember correctly, it has, yeah, a list of locals and a body. Okay. The locals, let's pass those locals around maybe. That's really just going to be a list of Waffle expressions, and then the body, Waffle body, has locals as an ID. I see, so all locals, and this is like the current body, I guess. Yeah. Something like that. And in here, optimizing a Waffle body using a Waffle fun, instead of doing this, we just have the locals, which will be a list of Waffle expressions, and we'll have the, what was it? The body. Oh no, the body is supposed to be the current body, but optimizing a body just yields a new body. So, okay, the body is actually just a list of Waffle IDs of the locals within that body. Crazy. Yeah, and then for every ID in the, oh, I see. In the body locals, we say in this global list of locals, I think we want to set that local to the optimized expression. Using all locals and the body. Yeah, that does seem kind of weird, I think. Well, it's gonna be fine. Oh, this call doesn't work because it has a Waffle fun. Outdated error message. Okay, optimizing Waffle fun doesn't create a Waffle fun builder, but instead it creates a list of all the locals, which is going to be a list of Waffle expressions. Yeah. And can we do like an uninitialized? Oh, there's uninitialized slice. There's actually uninitialized slice of some size, probably, of the fun dot locals dot size. Oh, that is nice. That is nice. And then what we do is we do locals dot set 0 to a Waffle expression where the size is, where did I have before? Fun.get. Yeah, copy. Yeah, that one. Add a len probably. Okay, you cannot set something. Oh, right. Only on a mutable slice. And let's make these ones actually accept a slice of locals. like they don't use the body here. They don't push any new instruction, any new expressions or something like that. So I can just do that. Locals without, oh I see. Well, fun and locals. And here we do locals.get the index and should inline. So for all the locals, we set the index to optimizing that. Oh, and the body stays the same because the IDs stay the same. I see. Yeah. Okay, so fun builder is not in scope. That is fun. Okay, so line 69, optimize that. Builder is not in scope. 122. Yeah, no, let's just return a waffle body with locals being, well, the body locals, they don't change, but the returns thing is optimized. Okay. Oh. Yeah. That is a body, and then we create a waffle fun manually with locals and the body. Beautiful. Let's see what happened. Oh, nice. Really, really nice. Oh. So now, ooh. Before the multiply function here would just create, extract the first number, it would extract the second number, then would call multiply with those two, with an aggregate of those two, and then return that result. Now, like these expressions, they are never referenced. Okay, so the inlining works. Basically now this immediately returns a multiplication of an aggregate of the first number extracted of the second number extracted. So we can remove these. So I think after the inlining we should add a like tree shaking, removing IDs that are no longer needed anywhere else. But then this function would just become a single line, everything working on the stack, no local variables needed. This one, let's actually look at that. Yeah, these are not used. Nope, none of these are used. We just do multiply of an aggregate of the constant 2 and the constant 1. And then here we do a plus of that result and the constant 4. That's cool. That's so cool. So let's call this not optimize, but let's call this inline. Because this is really, I mean, could call that optimize actually. Let's call it inline. Yeah. And then optimizing a function that means inlining things as far as possible in the function and then tree shaking that. Okay, removing expressions that are not referenced anywhere else. That is nice. So similar to this optimized stuff, and to this inline stuff, we now want some sort of tree shake functionality. Okay, so tree shaking an expression doesn't really do anything. You know, it, well, I guess it tree shakes the children. Yeah. This just returns the original expression. Same here, same here. For an aggregate, we actually do need to do something. We'll take the parts, which are waffle expressions, we'll tree shake them. For the member, yeah, we'll tree shake the off thing. Then for the switch, we do some other stuff. I want to tree shake those. Yeah, same for the call, same for call indirect, same for these. And then finally tree shaking a body. That's the actually interesting part. There we just check. I think we'll just go through the functions in reverse. We have a set of expressions that are referenced later on. Yeah. And then we just do, well, if the current expression is not referenced later on. And it is pure. Then we'll just continue on to the next one. And we build up this reverse body of Waffle expressions. Yeah. And otherwise we're going to add that to the body. Yeah. Reference later on is a set of Waffle IDs. Fair enough. I think I want to locals.set. Oh yeah, that's return. Supposed to return bool. True. And I'm kind of baffled by this one. I guess that makes sense. Yeah, the returns thing is never tree-shaped. That's actually pretty cool. Yeah, these are the, oh, I see. So this should really be, the body is a list of Waffle expressions, and for ID in ref body, we do the body to push that ID, and then this is just body to slice. I see. And here we also need to integrate the referenced IDs. Oh, let's first get the expression. the expression is pure, then we'll just continue. Fair enough. Otherwise, we are going to tree shake that, and then reference later on you collect referenced, something like that. So we need some sort of reference later on function. Hang on, some sort of collect reference. Into a set of Waffle IDs. Where we switch on the expression. Let's call this args maybe. Yeah, we need to do that on a body as well. And that basically goes through all locals. Yeah. I see. Yeah, okay, so this needs yeah, this does need a list of all locals. Yeah, I guess. So for every local, we just do, we get that, and then we do collect referenced locals and out, because this also needs locals, which we're gonna have to pass in here. Because if there's bodies somewhere in here, then like a switch with a body, then those need to be in there. Okay. Yeah, this needs the locals, which is already referenced. Okay, so tree shake does not work. Because tree shake needs stuff probably. Yeah, the body, it also needs the fun and the locals. Okay, tree shake some body. It's mutable. Okay, sure. Oh, I see. Yeah, let's kind of use this for these. Try to create waffle expression local with waffle expression. There is waffle ID. That is indeed true. So 268 returns is not a field on a list of waffle expressions because, oh, I see. Because we override body. It's like locals maybe. Yeah. Could also use a DAG in here. That would kind of simplify things, I think. Yeah, that probably makes sense. All right, but first, let's look at this. We have locals. Yeah, let's call it ref body, I guess, and let's call this not body, but forward body. You know, not the ref body, but, and this is the original body. Messy, really, really messy. Okay, 266. So we have this call doesn't work, push ID. Waffle body. Oh yeah, because this is supposed to be forward body. Makes sense. Oh, hang on. Unwrap body dot ref iter. That's important. Okay, ref iter. So this is the signature ref iter on that. You can only do that on a slice. So we will convert that to a slice. Those need to be IDs. That is true. And also these need to be IDs. Come to think of it. Ref body. Oh, we never pushed to that. That's also not great. So ref body dot push local. A list of waffle ID, not ID. It assembles, that's nice. Yeah, I mean, it's not really. It hasn't removed. It hasn't pre-shaped any expressions. Yeah, not quite sure what to do about that. Oh, I see. That makes sense because it's pure returns false for every single thing. Yeah, let's adjust that. So we actually have, we switch on the expression kind. Parameters, they are, I don't know, false, maybe. Padding is pure. Bytes are pure. Ints are pure. Referencing IDs is pure. Aggregates, well, they are pure if all of the inner ones are pure. For every part, if the part is not pure, then we immediately return false. Otherwise, we return true. Okay, for the switch, yeah, we should if the byte is not pure, then we definitely return false. And for the cases, it's a bit more complicated. I'm gonna add it to do. Then a call is never pure. Add, well, that depends on whether the arguments are pure. See. Oh, this is this shorter? I'm not sure. Probably not. Ooh, but this looks amazing. Okay. Wow. So here we have. Like, this looks amazing. Doesn't even have any local variables. Uses the stack perfectly. These down here though, they are weird. Like, why didn't that change? It stayed exactly the same. It's like they weren't even, you know, inline, not even. I don't get that. Every function is just optimized. I feel like we had better stuff than that before. Like in somewhere in here we had no, still not. Strange. Really strange. Okay, so why does that not work? Let's see. Yeah, this is the optimized waffle. Well, let's first start by printing this. Optimizing found.pick just to see if the main function is even optimized. Okay, we are optimizing playground main int. Fine. So we are optimizing the main function here. Which means we create locals, which will be an uninitialized slice, fun.locals.len. Perfectly fine. Yeah, then we inline the function body. And then we shaped body. Let's print those. Oh, they can't be printed to strings. No, why not? Let's see. Waffle body needs. Oh yeah, it needs the surrounding waffle fun and an int. Oh, hang on. Oh, hang on. Okay. Does inline. Why does it need the fun? Just for the recursive calls. That does not seem right. Oh, I see. In this inline function, we actually get the local from the function. There's a better way to do that, I think, and that is to just have this. I just copy the locals. Yeah. So for every local fun.locals, we just do this one right here, but for everyone. Locals.set local dot. We'll just push them, come to think of it. Yeah. Come to think of that's the same as copying all the locals. Well, and then inlining and so on, they only need the locals. That's pretty nice. For tree shaking, we don't need the fun either. Just have the locals. Yeah. Let's just see if this changes anything. So during tree shaking, you actually want to get the optimized expression. Not from your, this was the original function. Waffle ID, there's locals, look at. Ooh, that looks shorter than before. I like that. Okay, yeah, definitely. It's not, you know, super short. Oh, but the waffle is nice. So now when we multiply 2 and 1, we'll just do that immediately in here. No longer do this kind of crazy mess. Just everything tightly packed together. And that means this also uses the stack, because only the locals, they get their own, you know, kind of reserved stack space. But in here, we just do a push a 2, push a 1, and then call the plus function. Which, wow, that's amazing. That is seriously amazing. And then we do push 8 from stack. Actually not sure about that one. Oh yeah, we copy that result. Sure, yeah, this one. And then we push a 4 and we multiply those. Then we push that result to the stack. Then we pop things. Okay, yeah. And here we push the arguments, then we pop them. Okay, so I have some ideas on how to optimize stuff further, but before that, I want to first of all commit this, and add inlining and tree shaking to the waffle. Well, that's not really something intrinsic to the waffle. Inline and tree shake the waffle. Nice. All right. Okay, so let's clean this up a bit. Let's first create a folder, optimize waffle, and kind of move that in there. No, here. Yes, I want to move that in there and just call this mod, because I want to split this into multiple files. But first, I want to adjust the import in here. So this will be optimized waffle / mod. Amazing. Okay, and then in here I'll have a tree shake.mar file that does all of the tree shaking stuff, which includes this. And the mod.my imports that, so everything has everything in scope. Okay, and then inlining is its own file where this goes inside. And also this is going to use just mod. And the mod is going to import that. Okay, yeah. Nice. Step number 1. Let's see that this still works. And commit that. Yeah. Turn optimize waffle. Into folder. Amazing. Whew. Then I want to use the DAG in the waffle instead of having this locals thing. Yeah. In the pesto, do I use the DAG in here? I don't. Interesting. Might also be worth looking into, because the yogurt uses the DAG. The pudding therefore uses the DAG. Yeah, I think using that consistently makes a lot of sense. Alright, so the waffle should also use that. The DAG is the directed acyclic graph. Yeah, and rather than waffle IDs, we'll just have IDs, because there are nice utility functions like equal, checking if IDs are equal, writing them, getting something from the DAG using an ID, stuff like that. So let's actually go to the waffle again and say, in the waffle we have functions, correct? Every function has a DAG of waffle expressions and a body. We don't have waffle IDs. Nope. Explicitly here, functions don't have explicit parameters. Okay. Then we have the body. Every mentioning of Waffle ID is just ID. Nice. That looks pretty cool. Is there stuff where now things fit on a single line? No, probably not. Okay, that looks, all of that looks fine. Then the next step would be to writing Waffle. That is something that I want to change slightly. Rather than passing around the function for writing, a body of writing expressions, which is, writing expressions only passes that to the write function for other expressions, like you can see in here. They just pass this on and don't do anything with the function. And the parse body, the only thing it does with the function is getting something from that. But instead, you should just use the DAG directly. So the DAG of Waffle expressions. That's what we really want. And then, you can, write the function body using the function DAG. And here let's unwrap the signature and the, I guess just do that. Is there an ID constructor for that? Not really. Let's create one. And also use that down here. Okay. So we can just do ID 0. Okay. Amazing. Then writing an ID, there's a generic version for that in the DAG module. Okay, here we don't need this, we'll just do dag.get, which is amazing. Yeah, here we just pass around tags. Amazing. Wow. I feel like we also had something for indentation. Yeah, we do. Of course we do. Indentation of some amount. Yeah, let's say this is just indentation, because then we can just do write that indentation. And everything else stays exactly the same. I mean, here we can say and then write the indentation of with an indentation of 1. Okay. And the DAG is actually just a DAG of Waffle expressions. Wow. Yeah. Does that work? No, probably not. Yeah, makes sense. Waffle IDs don't exist, so in here, let's just look for Waffle IDs. This is like pesto to Waffle. This would just be ID 0. Amazing. Yeah, here we have a mapping fun ground builder from ID to the integer. Yeah, everywhere that occurs, we just use IDs directly. Here we have in tree shaking and so on. Let's just use IDs. Okay. Oh, that's probably in the waffle. So in the waffle, yeah, we don't need these. We don't need these. And we also don't need this, because we can just use the waffle tag. Nice. Really nice. Yeah. Yeah, I mean, of course that breaks. That's to be expected when you change these kind of fundamental things. Okay, so we have a builder, a waffle fun builder. What is a waffle fun builder though? It's just a list of locals. No, let's not even have that. Waffle body builder? Yeah, that may make sense. Yeah. No, that's just a reference to the tag of waffle expressions. And these are the locals. Oh, alignment is a thing here. Interesting. Okay, so waffle fun builder, another thing. I'm sure let's create, a tag for waffle expressions with a parameter. Let's create a tag and then say tag dot push. Say tag dot put, like this one. And then return the tag. Then again, you could just do that wherever that is used. So that was waffle fun builder used. Builder. To waffle. Let's instead create a tag. Well, yeah. There will be param layout.size and param layout.alignment. Okay. Amazing. Back to here, we have a body builder and a tag waffle expression. It's going to return a waffle body builder with a tag. That's just the tag. Then locals, which is a empty list of IDs and an alignment of 1. Okay, this defines a local. Yeah, no, we just do builder.tag.put. Oh, that is already a reference. But put the expression in there, please. That returns us an ID. And that ID we push to our locals. That is nice. That is really nice. And then we return a waffle local of that ID. Amazing. Okay, let's turn this into like finish, which is the usual name I use for that now. Builder is a waffle body builder. returns something, this expression. Yeah, and locals is just going to be local struct to slice. Finish is not really a thing here. Yeah, okay. So where are things failing? Yeah, converting pesto to waffle. Yeah, we have this pesto stuff. And then we just have a tag. Oh, hang on. The bodybuilder already has that. Fun builder. No, 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 no. Just a tag. Waffle expressions and oh, this actually makes sense. Yeah. Is that used? I'll figure that out at some point. Okay, so what we do is we create a body builder using the tag. Okay, and then for every ID we just say do that. Convert that to waffle using the builder, using the mapping, using the pesto. Add a mapping for that. Boom. And builder finishes with whatever the body returns, giving us a waffle body. To waffle on a pesto function says to waffle on the tag. And in the end we just return a waffle fun with the tag and the body. Even shorter than that. Nice. Yeah. Yeah, okay, so in many places we call to waffling. Oh, not in that many places actually. Yeah, let's go through them. So for each of the cases, which will be things, which will be bodies, yeah, we'll need to give them the builder tag, which is a mutable, like a reference to that. Then for every, say we want to convert a, yeah, that actually makes sense, okay. In here that makes sense, and that makes sense, okay. So this is the signature, get waffle fun ID. Nope. Here we just do waffle.get, which is fine, I think. Stuff gets simpler in line 329, where we just do new line, then indentation, like that. Actually makes sense. And here we can also just do indentation, and then that one. And here we can even do that one. Look how concise that is now. Yeah. Hang on. Oh, and optimize waffle. That's true. So optimizing a waffle fun. means we build our own DAG of waffle expressions, and for every expression in the function DAG, we're going to put an expression in our DAG. And then we just do these inline things using that DAG, pre-shake stuff using that DAG. And in the end we return a waffle function with our new DAG and the body. Yeah, this doesn't change. For expression in front of DAG. Oh, I see, it's like DAG dot nodes or something. Makes sense. Local is not in scope. Yeah. Okay, yeah, so inline has, you know, should inline on this, and it also has this locals thing, which instead should just be a DAG clean. And then we can just do DAG.get of the ID. Yeah, and all of these calls just pass the DAG instead. Actually, let's okay, this doesn't work. Oh, this one. Oh, I see, because this one should also accept DAG instead of locals. So for every local in body.locals, we do DAG.set ID to DAG.get that ID inline. Crazy. And in the end, we have this thing with the body local, they stay the same, and the body returns. Yeah, we're gonna inline that. Makes sense. Oh, DAG is, oh no, DAG is supposed to be a DAG. No. Okay, so DAG set is not a thing apparently. Which is fine, you know, let's add that. So given a DAG, now given a mutable DAG t and an ID and a node, we should be able to do DAG.nodes.set ID index to the node. Yeah. Very nice. Then tree shaking. Okay, so here actually we have these helper functions, is pure and collect reference. Yeah, let's put them at the beginning of this file, I think. Yeah. So is pure doesn't do anything with DAGs or something. This really just accepts the DAG and thereby fits on a single line. Here we do this part, collect reference, but let's instead pass in the DAG. Amazing. Same here, this should accept a DAG. Okay, and this one here, tree shake, returns a DAG. Yeah. Oh, hang on, this one actually collecting these doesn't need a mutable DAG, it just needs a DAG, so that should be fine. In here we do tree shake using the DAG. Yeah, okay. I think that is actually pretty cool. What's going on here? We don't need these, and this is all messed up. How about we don't do that and just do stuff like this? Maybe align that, sure. Okay, yeah, that's the kind, and then we return the expression in the end. Perfect. And this is a DAG. Tree shaking, that makes sense. Reference later on, we have the body, we have the ref. Now we can call these locals. What? That makes sense. Okay, yeah, I like that. What's going on here? Oh, yeah. Cool. Collect referenced. Oh, I see. So this should pass the DAG like that. Sure. Okay, so waffle to ground. Next compiler stage. Get an int. Oh, I see. Yeah. Do we use that? We do. How do we use that? Tending towards saying this is just param stat, and then this is just something like that. True. Yeah, we instead need to do that. This call doesn't work. Compiling. Yeah, true. But that is fine. Okay. Okay, found out locals is not a field, and that is very true. Okay, yeah, this is the exact same code as before. Hopefully, yeah. Yeah, nice clean multiplication and addition, multiplication, okay. But now with the DAG, use DAG in Waffle. Use the DAG in the Waffle. Cool. Then, what now? What else can we do, basically? Okay, so there are several things. First of all, something we can't do in the Waffle alone is something like this. This references the arguments struct, and then the thing at offset 0 with size 8. We can't trim this down any further. But how that is compiled is we first compile this right here, the 0, which will kind of copy those 16 bytes to the top of the stack. And then we get a subset of these. I think we want to special case this very common thing of referencing some existing stuff and then getting one part of that to only copy the necessary part to the stack. That's not entirely in the Waffle though, that is instead in, yeah, exactly here, in Waffle to ground, where if we compile some expression, and that is a member expression, then what we really want to do is check, kind of special case, is that a member expression of a local? And if member.off.kind is local, then we want to do something special case. Else we do this generic stuff, where we kind of compile the entire expression, and then we extract the stuff by removing the bytes after the thing we're interested in, and removing the stuff before the thing we're interested in. Instead, we'll only copy the thing. Okay, and this is basically this right here, copy from stack of that local thing. And that doesn't quite work in our use case, I think, because we don't have an ID for that. But where is that defined? Copy from stack. Yeah. Here, copy from stack of some ID is just copy from stack from the stack mapping, which gives us the offset of that thing on the stack, and this size. And what we can do is we can just say, copy from stack, get the local variable plus the member offset. And then the member size. Expression.size. Yeah. One case. this definitely warrants an explanation. So quite often you see things like this in the waffle. For example, if we have an aggregate representing the arguments of a function, and we want to get a single argument, we extract that argument. Lowering this in a naive way, first lowering at 0, where's the at here, then lowering the member access leads to crazy amounts of copying. Copy the entire argument struct to the top of the stack, the entire local, and the entire local aggregate, I don't know, to the top of the stack, just to then discard the majority to extract the field we want. So here we special case that pattern. Amazing. That makes a lot of sense. Let's see if that works. Look at that. Whoa. That is way shorter. Okay, so we're pushing a 2 to the stack, a 1, then we call the plus function, which is an add 10 down here, which says, yeah, fair, we push 2 arguments to the stack, we multiply them, and then below the top thing we pop the arguments that we were given, then we return. Yeah. Yeah, that does make sense. I think. This is still not optimal, you know, but it is way better than before. Let's maybe look at some more complicated code, I guess. Let's also commit this. Yeah, special case, member of local. Amazing. Let's maybe look at making a list and getting the length. Make this 2.9. Ooh, okay, so some things are not working. Dang, that is a lot of waffle. Okay, here's optimizing. We're optimizing stuff, and then we're printing the optimized waffle. Ooh, like this is still a lot of stuff that we can optimize. Okay, so first of all, we have a switch with only one variant. One body. That means, which is by the way weirdly, let's not use curly braces for switch bodies, I think, because they are basically only used for aggregates. So that would be in the waffle printing. Down here there's some printing a switch right here. Let's not have that, let's not do that, let's just boom. Okay, so we are switching on some value. Ooh, and this is also nice. Like we are accessing the first byte. Now this is an expression with size 1, and we are accessing a member at offset 0 with size 1, aka the entire thing. We can just remove that member, and this one as well. Yeah. Oh, I'm just wondering, like, I want to do a lot of these kind of tiny optimizations of these obviously more complicated than they need to be cases. I'm wondering where they should go, because inlining, like having these separate passes for these things, maybe that's not the right approach. Maybe not. Maybe let's say, rather than first inlining everything of a function, then tree shaking that, we kind of interleave stuff. Because a lot of this, a lot of this right here, going through all of the expressions and basically only mapping that. We only, like, for the majority of cases, we just say, oh, we have an addition, let's emit an addition. But inline the arguments. Like, oh, we have a subtraction, that's, all of this is just boilerplate, basically. So what I want to do is basically, let's merge these maybe into some, optimize. Optimize function, yeah. Though I am wondering, like in the inlining, we walk the function from top to bottom. In the tree shaking, we walk it from bottom to top. Like that is, that is just kind of difficult, I guess. I don't know. Okay, I mean these, maybe I'll add a separate pass for these. Maybe some, remove, so, but that is optimizing. maybe this is going to be optimize. And tree shake is kind of its own separate thing. Which is also weird, I don't know. Yeah, let's do it like this for now. So this is basically the forward pass through the waffle that a lot of optimizations will probably use, where you can, you know, do a lot of stuff, and the tree shake kind of cleans up afterwards. So let's not call this, let's call this optimize, I guess. Optimize a waffle body. I think this is actually, we can still interweave these two. Like, you know, this is an optimizing this expression, and we assume that all expressions in here are optimized. Yeah, let's maybe write a little comment. Optimizes the expression, assuming that it only this function assumes that all expressions that this expression depends on are in the bag and already optimized. That's it. So that's the way we can optimize a waffle expression. And then in the body, we'll just do optimize a waffle body. Yeah, we'll go through the expression in order, optimize each of these individually, and then it will do some sort of tree shaking, where it will, we have a lot of like this stuff and this stuff that's still valid. Yeah, but this one right here, we don't need this. Instead, only in the body, yeah, we do this. That doesn't make any sense. We don't need this big function, because we can just say tree shake this body, please. And we'll just go through the tree shakes in the body, assumes that any expressions within this body are already optimized. Then tree shake of that just goes to reference later on as a set of IDs, okay. Then we have we build up these reversed locals. I think actually we should also add the what this returns, by the way. And watch, oh, yeah, basically do that. Body.returns, which is an expression, you know, collect the referenced IDs. Yeah. Why does that need a DAG? Collect reference. Just passes the DAG on, passes the DAG, DAG, but it doesn't use the DAG. This should not depend on that. Nope. Nice. Then we build go through the body from the bottom to the top, tracking which locals are used later on, are required later. Yeah, referenced later. This way, when we encounter an expression, we can immediately know immediately whether we can throw it away. Yeah, ref locals, and then we go through the locals of the body in reverse iteration order. We say please get that corresponding expression. If that is not referenced later on and the expression is pure, then we'll just continue. Otherwise, we collect the expressions that this expression references. We update that. That doesn't make any sense because we just got that from the DAG. Oh, I see. Oh no, it returns a new waffle body. Okay, yeah, that's fine, I guess. Collect referenced, okay, and then we do ref locals.push. And then we build the forward locals. Yeah, amazing. And then in here, we have a waffle body. We optimize all of these, and then we just say the body is that. Dot tree shake. Clean. Yeah, tree shake with the DAG. That is nice. Collect stuff for the body doesn't, I know that shouldn't depend on DAG. Oh, hang on. Oh, okay, yeah, I see. Well, yeah, because this expression may contain other expressions that, and may contain a switch that then contains other expressions. expressions, hang on. Yeah, okay. I see. Okay, so this does need the DAG. Fair enough, fair enough. Entry check 90. Up here, DAG is not even mutable, is it? No, we never set anything in there. So this function is shell, only removing the from the current body, not inner bodies. Yeah. That is nice. That's really nice. Yeah, these are not separate parsers. No, just optimize the body. And that immediately tree shakes the body. Clean. Yeah, okay. Damn, that is certainly stuff. So let's look at this, and let's say refactor, you know, yeah. Okay, but now we have this, you know, generic optimize function on an expression that can assume that all referenced expressions are already optimized. That allows us to do some nice stuff. For example, I mean, yeah, padding of 0, we can't really optimize that. But if that is in an aggregate, for example, like in general, like if we have, you know, part is part dot optimize DAG. Now we can just check, you know, if the part size is 0 and the part is pure, then we just continue to the next part. We don't need to add that to the aggregate. Like in here, for example, a padding of 0 in the aggregate. Let's remove that. This one right here, let's remove that. Hey, yeah, this looks simpler, definitely simpler. Casting false to true or false. Just an aggregate with an aggregate with a single item. We can just return the item directly. Also, I guess in the printing. Yeah. So if parts.length is 1, then we just basically evaluate to parts.get 0.count. The size matches. Otherwise, dictionary. Cool. So now things get even simpler. Yeah, converting false to true just creates the byte 0, and that's it. We can let's optimize the printing so that if this has no locals, this body in here, but only a single expression, then we don't even have new lines in there. I think that would be even cooler. I guess. No, let's not do that. I mean, it might be cool for stuff like this. That does not seem correct though, does it? Because we should dupe the pointer here. If it's more, then we should dupe the pointer. Yeah, let's do some so many things I want to do. Okay, I guess let's first of all, yeah, let's adjust the printing to make that a bit more nicer. So in a switch, I don't want to put these on a single line, but I do want to put quotes around function calls. So I have a call, and instead of just printing the function, we'll print quotes around that. Okay. Okay. This is weird. This is really weird. I want to see if that is also happening before. So in here, the waffle does seem larger here. So the optimizations, they are doing something. Okay, so is equal. Okay, and this is the yogurt. True, then we have the pudding. Okay. Then the pesto, I guess. So the waffle. Okay. Yeah, here we are switching on the enum. Then in here we remove this store. That is that's bad. So tree shake. Collect reference. That is true. That is pure of a store. Oh no, that does not only depend on whether the this is pure, sure, and this is pure, but the store itself has a side effect. So stores, loads and stores, they are not pure. They need to be kept around here. Also, free is not pure, and malloc is not pure. No. I mean, no. And crashing is also not pure. Should not just remove a crash expression just because the argument to that is pure, you know. Shouldn't remove mallocs, free, loads, or stores. Yeah, these are fine to remove. This as well. Calls, not because the call may crash or allocate memory or do something or freeze something. Yeah, switches, they are not pure currently, but we may change that. Okay, aggregates. Yeah, okay. Okay, cool. That makes sense. Oh man. Okay, several instructions. Hey, this is the optimized waffle. This is pretty cool, to be honest. Yeah, before there was like an aggregate with padding and stuff. This, I want to simplify this. So if we have a member, optimize, and first of all, optimize aggregates. Several things. First, bug fixes. Fix is pure. Then optimize aggregates. Then update printing. I don't know. Okay. Then members. What can we do here? Here are members. For members, I want to check if, first of all, if the member off. Oh yeah, first optimize the member off. That's the first step. You optimize that inner thing. Okay. Then, if that is, if the size of that equals our own size, well, that kind of implies that the offset is 0, you know. No. I mean, this member is useless, completely and utterly useless. And also, if, well, okay, I get to that. We just return the off thing directly. That makes sense. Yeah, this is not really needed, I guess, because if the sizes are the same, then the offset is guaranteed to be 0. But I think this is a bit cleaner to have it in there. Right, even cleaner, have an assert. Oh, there was no assert, right? Weird member. Okay. Optimizing stuff. Oh, look at that. We just switch on that directly. Amazing. Now, we can even, we can simplify things even further. If there was only one branch for a switch, we can optimize that. Show inline. Now switch. If there is only one branch, oh, that is actually, you would kind of have to, if there is a branch with multiple expressions, we would kind of have to create new locals in the current body and stuff like that. That's not as easy as it seemed initially. Well, okay. This makes sense. Yeah. I'm not sure about these ones. Like in general, I don't want calls to be inlined somewhere else, because then there would be two calls. That's bad. Maybe I'll need a separate pass or something like that for, if we have, basically if we have a call and the result of that is used only a single time. Right, here's the optimizing stuff. Yeah, like here, we have a call and the result of that is used only a single time in here. And there was no call in between, like in this case, because this call happens after its arguments are resolved. Then we should also be able to inline that call in here. And that would actually give us this nice, like using the stack really effectively. You're just calling the compare function, calling the compare function. The compare function is just like pushing the result to the stack. And then we call the is function without even touching the stack. And the is function just consumes the stuff that the compare function pushed. And yeah, I'm not entirely sure how to do that. And then we wouldn't even need to, give this and we wouldn't need to return an ID. We could also have this one giant call chain basically down here. So we wouldn't even need any local variables in here. And also the arguments, they should, not sure, because it's kind of unfortunate that the arguments, that the parameters to a function, they immediately introduce a local variable that we copy every time we use that. If we only use that for the first function call, for example, I think we should be able to kind of, you know, put that in there. Yeah, I don't know. I might change how parameters work in the Waffle. But I'm gonna take a break first. Okay, before I optimize anything further, I think I'll change how the Waffle is printed to, you know, better support deep expressions. For example, you know, this works, but if we would, you know, inline that in here, for example, like things get really messy and yeah. So here we go, Waffle. Oh, hang on. Before that, let me check if there is something I should commit. Yeah, let's do that. So member how do I call that? Like optimize members? I don't know. Yeah. Right. Writing the Waffle. The function just has the signature, perfect, and then the arguments, the individual expressions, and the local variables, yeah, they have this annotation, and then the ID, and then the size. Okay, I guess. In here, let's actually print aggregates on multiple lines, for example. Let's just print your aggregate, and then just purely indentation based. Do not this, but instead write a new line, then the indentation +1, I believe, and then then a value. And member, yeah, let's also do something similar there. So I mean, I guess for members, let's do that. It's fine. No. Member at, and then the offset, okay. And then that one with more indentation, cool. For switch, we have the, oh man, the just switch, I guess. Then the byte with the condition indentation +1. Rather than this, we just have let's write a case in there. Not entirely sure about that one, but yeah, sure. And then writing the actual expression. For calls, let's put here like call and then that, and then just a new line. For indirect calls, do like call this. Well, call indirect, sure. And then this with indentation +1, and that with indentation +1. Function pointer with the signature, and let's put that in quotes. For the add, we'll just have the add, and then the body with more indentation, Similar for the sub. That's just a sub new line thing with indentation +1. Mul new line with indentation +1. If new line with indentation +1. Oh, mod new line indentation +1. Compare 0. New line indentation +1. Yeah, let me maybe this new line and indentation +1. Okay, yeah, malloc, same thing. Free of size. Hang on, free has a size. I think that's the. Is that an int or is that an expression? Free is a waffle expression, the expression to free, okay. That is okay, not sure about that. Well, let's just see what happens if that makes sense. Oh, you know what, let me maybe also comment out the printing of the ground and the bytes, because that's mostly noise right now. Okay. Whoa. That is certainly something. Okay, so we switch on 0. Yeah, I'll just add new lines where necessary. The locals, I'm actually gonna print them like this. Yeah, local, and then the ID, and then the size equals, and then just these with more indentation. And not have that. Yeah, bodies just print a new line at the beginning, which means in the switch we also don't need a new line here. Okay. Okay, so local equals something. I think when you print an expression, yeah, I think you should be responsible for printing the annotation as well. What does that local is at? Yeah, let's not do that. Okay. What is going on here? Okay, so we're optimizing stuff. This looks fine, I would say. Yeah, we have a local variable in here. That is just a switch with switching on 0. If that is 0, then we just do that. Hang on, where's the body? Oh, compiling. No. Just want to get into the printing. Here it is. Okay. So we write expressions. Yeah. Then an indentation. Okay. Oh, I see. There needs to be a new line here. Before the return value. Okay, that makes sense. Okay, local 0 is a switch on 0. Makes sense. And here we have case 0. The switch is here. Yeah, case that. Then we do this. We print indentation plus 2. Apparently that is not working correctly because in here we don't need to print the indentation because the return expression already takes care of that. I guess, yeah. Let me zoom out maybe. Yeah, that looks kind of fine. Aggregates are really weird and stores weird, but we're slowly getting somewhere. So, okay, this function actually just has a local in here. We switch on 0. If that's 0, then we just return the byte 0. Perfect. Perfect. Then we have this equals function where we have this aggregate. That does not seem correct. Okay, so we have an aggregate, and we don't need to print that indentation because expressions take care of printing leading indentation. The other cases where we print indentation, Not really, I think. Oh. Okay. Okay, after aggregate, there should be a new line. Yeah. Oh, hang on. Oh, for each of these fields, we want to print a new line and then the field. Yep. Oh yes, that looked nice. Okay, yeah. Cool. So we have this local variable. That is just a switching on 0. Case 0, we return the byte 0. Then we have this, an equals function that first defines a local variable by calling something with, this should be indented, I think. Yeah. So for the call, oh yeah, this should have notation +1. Yeah, we call that compare function with an aggregate with this member and this other member, both of the arguments. Nice. Then here we have the local variable. That is this. Well, colon is equal of that. Makes sense. And then finally we return that. Here we return an empty aggregate. And this is just a local variable that is basically ignored. Here we switch on the member of this at position 8, size 1. If that is 0, it's just an empty aggregate. If that is 1, then nice. Then we define this right here, a local variable, as adding, well, stuff. Adding, oh, this aggregate, I see, of this one and 1. So adding the load 8. I am getting the first 8 bytes of that. That's basically the pointer, loading that. Okay, yep, makes sense. parameters or arguments, I'm gonna print them differently, I think, by not having this, but instead just writing down well, basically writing the new line and then indentation of 1. Then writing local ID 0 of that size of, well, fun.dag.get ID 0 dot size equals param. I'll just here param. That would also be nice. Yeah. So parameters to functions are kind of, you know, explicitly written in here. That's cool. Right. Ooh, okay. What else? This compare thing is kind of weird. You know, that we built an aggregate of the same expressions instead of just having aggregate, instead of just passing 0 into here directly. But I guess, and later on, it doesn't really make a difference in the, you know, in the bytecode thing. So, meh. Okay. Yeah. The thing I want to look at now is basically nesting function calls. So if we have this right here, yeah, I want those functions to be nested. Like this looks mostly fine, I guess. This as well. But in here, this shouldn't be, you know, a local of a local. This should just be nested. This function shouldn't need any local variables. It should just immediately return a call to plus of an aggregate of a call to multiply of an aggregate of 2 and 1, and that's it. Yeah, so I'm not entirely sure how to do that. Basically, I want to inline calls, I guess. Like I want to, if I'm looking at this call and I see this 5, want to basically realize that between this part and this part here, there are no impure instructions happening. There was no load or store or function call, you know. So this, only then should this be kind of inserted in here, be nested. Yeah, and I think that is probably its own optimization path, paths similar to tree shaking. But let me first, you know, commit this better printing. Yeah, sure. Improve printing of Waffle. Okay, so I have the, it will be somewhat similar to the tree shaking actually, I think. Just a bit different. A bit more involved, I guess. Yeah, just inlining doesn't work, because we don't just want to also put that down here. We want to only put that in here. If, like, this call should only be called a single time. So only if this local is only used once, we want to put that in here. All right, so I guess let's inline, not inlining really. No, more like collapse. Not really. Like inlining usually refers to copying the bodies of entire functions, which is not at all what we're doing right here. Short inline is also kind of basically can copy, maybe. That would be more semantically meaningful here, I guess. Like an aggregate can be copied, byte can be copied, int can be copied. The malloc should not be copied. Free should not be copied. Load and store should not be copied. Okay. All right. So what are we doing now? Let's create. I don't know, compact nest, I think. That will be similar to tree shaking. Tree shake and nest. Yeah, this is, like, is pure, sure. Collect reference, well, yeah. Nests. Expressions. When possible, instead of having local variables, instead of having locals. So we take a body, we take a DAG. Yeah, I guess that's correct. Yeah. Is it though? No, no, not quite. No, it does take a mutable tag. Used, referenced. Well, nests expressions with exactly one occurrence. Instead of having locals, if that does not cross a call boundary, does not cross a call, yeah, something like that. Okay, so we have basically like num references. Yeah, basically we want to count how many references there are. So like have an ID and out. There's something like that, I think. Something like that exists. I'll put default. Sure. Yeah, so local, oh, I mean this is only used there. Well, sure, like that. Okay, yeah, for these it is, yeah, out should be a map from ID to int. That goes here, perfect. References. Know immediately if it is exactly once. Perfect. Count references of reference later on. That is not in the scope. That is true because that is supposed to be num references. And we go through these, we see some sort of local. What we want to do is we want to get the expression. actually not sure how to do that. I mean, we basically want to go through the expressions. Okay, I do think we want to, first of all, go through everything, find out how many references there are for each and every single one expression. And then we want to go through that entire thing again, kind of go into the expressions and be like, hey, here's a local. Okay, so then on the next local, we will kind of offer, hey, you know, by the way, if the 5 occurs anywhere in there, then you may want to nest that. Something like that. It does seem weird, but yeah. Nest calls with one usage, with one immediate usage, something like that. So we go through the body from the bottom to the top, tracking which locals are referenced later in the body. This way, when we encounter an expression, we know immediately if it's referenced exactly once. Okay. So we check. No, we don't do that. We just count the number of references. The body returns thing, and also for every local in the body. Okay, so now we have all the references. Yeah, let's get this. Okay, and now we go through the expressions again. Kind of, you know, recursively. Yeah, last, I don't know, is an ID. Well, not last, but you know, the previous thing. Previous call, maybe? Previous local. Oh, yeah, that is. That makes sense. Mm-hmm. Okay, so what we do is we switch on it. Why does this not work? Oh. Okay, sure. Switch on the kind. If we see some parameter, then that should be unreachable, I think. If there is padding, yeah, you want to map these expressions, I guess. With the kind, the size being the expression size, the alignment being the expression alignment. Wonderful. And then we have this padding, that is Waffle expression kind padding of some amount. The byte is just a Waffle expression kind byte of that byte. The int, similar with the int. Okay, if we reference a local expression, and that's the previous local. And then we instead inline that. So then we just return deck.getID. Else we do Waffle expression kind.getID. Get local of that ID. Yeah, for the aggregate, hang on. Let me copy this maybe. That should be a bit closer to what we want to do. Yeah, here we build the parts. I think this should maybe return result. Like a maybe, right? It tries to nest the previous local inside the expression. Yeah. Let me take a quick break. Okay. Not entirely sure. This can basically return like 3 possible things. Nest result. It's either, if this ID hasn't been used yet, not used yet, and you get back an expression. Yeah, or it returns call not immediate. Or it returns used. I'm wondering, do we need to distinguish between these two? Probably not, because we know that it is only used exactly once. Okay, so maybe this maybe is actually enough. Tries to nest the previous local inside the expression. If it cannot, if impure expression happens before the previous local is used, such as call, store, etc., then we cannot nest the previous local directly in here, because that would change the order of impure expressions. In that case, this function returns none. Okay, yeah, that makes sense, I believe. So we just assume that everything works here, and we just return some that. And then in here we can just check, you know, is this an aggregate? Then we nest this expression in the parts. So nest the locals with one immediate usage of the bag and the previous local. Yeah. And we kind of push that in there. But that may not work, and we'll just bubble out. And these kind of optimizations, we don't need to do them because they have already been done. Okay, for the member of, we try to use that in there. Yeah, part member.off dot nest locals with one immediate usage. And then, yeah, we create a member. Okay. For the switch, we first evaluate the byte. So we need to do that first, actually. That's going to be switch byte. Nest locals with one immediate usage. Boom. Yeah, if it happens within a case, that is not valid. Yeah. Okay, so cases, we just take them as is, I guess. Yeah, so let's do, the cases stay exactly the same, I guess. So that's just gonna be switch dot cases. And this is the byte. Okay, yeah. But also not quite. Well, you know what, let's just return none here. Basically treating a switch like a call, for example, or an impure thing. For now, at least. Yeah, if there's a call, now this is interesting. And we try to oh, I see. We want to do that, you know, member dot, well, call that args dot nest locals with one immediate usage tag previous local. Yeah. But wasn't used in there, then we also want to disallow doing, like, trying to propagate the ID even further. So we do need to separate. We do need to separate between a nest result not being used yet or being used. Could do something like that rather than that. Yeah, and in here we kind of do used equals true. Nice. That does mean that yeah, in the call, that may not cross the boundary here. So basically, it cannot be used after the call. So if it's not been used yet, oh yeah, then we just return, nope, doesn't work. Same for the indirect call. Yeah, we first evaluate the function pointer. Then the args. And then the yeah, and then we have something like this. If it's not been used yet, at this point, just return nope, not good. Yeah. This is all just nest. Oh yeah, this should not optimize stuff. This should just be the args put on the heap. Oh man. Oh, that is kind of ugly, I have to admit. Well, oh, and I do need question marks after that to bubble out if that didn't work out. Okay. this call makes sense. Function pointer, add, subtract, all these arithmetic operations, sure, that's fine. But here we want to do something different. We say the size. Oh yeah, is that. And now I also want to check if the expression has not yet been used. Then we don't want to nest that. Okay. Otherwise, we'll put a malloc with a size. Okay. Same with free, where the free contains something. Yeah. Or with the load. Like for example, the load should not be able to cross a free, for example. Yeah. Ooh. I'm just realizing that we could even be a bit more lenient about that. We could, for example, allow store instructions to cross each other, but not, or load instructions to cross each other, but not load and store instructions to cross each other. Or not calls to cross each other, but if there's, yeah, something like that. I don't know. But if there's a malloc and then afterwards a call, I don't know. I'll leave it like this. I can always see if that's actually a problem when using code. Okay, so here I want to do something like that. Boom. Except, oh yeah, with a pointer and the value. And if it's not been used, then we will say nope, not good. And here we just have the pointer and the value put on the heap. This is a crash. Yeah, that does work. We could say args is this basically. But then we should also say if it's not used now, then it shouldn't be allowed to cross this crash expression. So here we say that. So that is kind of cool, kind of complicated, kind of wacky, but it is cool. So nest locals with one immediate usage. In the optimize case, I want to tree shake some body. Okay. Yeah. Let's actually do this. Then let's say body is body.nest locals with one immediate usage. And this only works on expressions until now. Oh, it does work for bodies. Okay, interesting. But with a mutable tag. Makes sense. Yeah, we don't need reverse stuff, and here we just need to get locals. And then basically for every local, we just build, we get the expression. Yeah, this is not something we want to do. All this. Okay, basically want to get the previous one. Previous is locals dot get maybe. Well, let's do like for I and so to locals then we get the local. That's just locals dot get I. We get the previous, that's get maybe I minus one. Or if that doesn't exist, I don't know. If that doesn't exist, then just do that. And we push the local. Okay, but if we have some local expression and we have a previous expression, we can check, hey, the previous one is that only used a single time. If num references dot get previous, if that is 1, then we can attempt to, you know, inline that in here. So we can do locals. We can do locals dot dag dot get local as an expression, yeah, and then do the nest locals with 1 immediate usage. That down there with, what's a body? No, that's an expression. With the dag and the previous one and the used one here. Yeah, and if that was used, oops. Or if that doesn't work, then we'll also just push the local and continue, I guess. Yeah, but if that worked, and then we'll actually pop the previous one and only push the current one. Well, that's weird. That is really weird. Oh, hang on, this is that, yeah. Mm-hmm. let's do it like this. Let's push the local either way. And then here we can just say or continue. That makes sense. Now we'll check number of references previous, and only if the if the previous one has one reference, then we'll even do something. Yeah, we'll try to do that, or if that doesn't work, we'll just continue. Yeah. If that is true, then current pop previous push current. I'd be surprised if that worked, to be honest. Okay, sure. That is indeed surprising. Let's move that to the bottom. Nest locals with one immediate usage. Nest locals with one immediate usage. Okay. And in here, we nest locals with one immediate. Oh, I see. And the mod. We want to import that. Okay, count references. Doesn't work. Oh, there's an ampersand tag. Oh, I see. 200 in here. Yeah. Nope. Nope. Inconsistent return type. 969 mail. Where? In nest. Yarn nest. Oh yeah. Oh yeah. Then we're just like, yep, that worked. Yeah, this needs the DAG, the previous local, and whether it's used. Same here. Which, by the way, is horribly verbose. I see that. Oh, that can only be used on results, really. That is surprising. Okay, sure. I'm just gonna return a result of Waffle expression and nothing. I'm fine with that. Why though? That is true. Okay, this call doesn't work. This is the signature. Waffle expression. Nothing. Oh, it needs a nothing. That makes sense. I do want to take a walk, so I'm gonna hurry up. Oh, it compiles at least. That's something. Well, okay. So we're not doing that correctly, but let's look at that. Oh. No, we're not doing that correctly. Not at all. We have this 5 in here, but we don't define the 5. This should be replaced with the previous one, though. Like, hang on, we have, what do we have? We have a call. Okay. So we say arguments. Hey, arguments, please nest locals with one immediate usage. Apparently that works. So we have a waffle call of the args put on the heap. Sure. And then inside that is actually an aggregate. This one right here. Or we build these parts of waffle expressions and we say, hey, please push this one. Nest locals with one immediate usage of what it was previously. And we built those parts directly in here. Seems correct. So then we say, if the ID is the previous local, then we say, hey, this was actually used. So here's the previous local, the expression for the previous local. Yeah, okay, sure. Let's debug print that. See what that is. Okay, yeah, we are using the previous local boom. This is a call to a multiply function, etc., etc. Okay. Oh, hang on. Down here, do we actually use that? Like, we place that in the DAG? I think not. New version is that. Okay, and then we just should do dag.set local new version to update that. Let's see. Okay, this is pretty cool. So here we just have a single local now, which is calling the plus function with an aggregate of the result of calling the multiply function with an aggregate of 2 and 1 and 4. I think we should do the same for the last expression actually, so that we have no locals at all. But I'm gonna do that later after taking a walk. Okay, so I think what's next? What would be cool is to merge these. You know, instead of accepting the parameters and then getting the first integer out of them as this local, then getting the second integer out of them as this local, and then aggregating them again. It would make more sense to just directly pass the parameters further down here. Oh, hang on, this is not even the optimized version. Yeah, okay, here we do a multiplication of the aggregate of these two members. Oh yeah, but inlining the parameters here is difficult because the 0 is used 2 times. So even if we would, allow, if we know that, hey, the parameters are on the stack, we can't just immediately pass them to the aggregate function because we actually use them 2 times. And I think let's try to merge aggregate members that are actually like consecutive slices of the same value, of the same local. Like, it doesn't make sense to have this 16 byte memory thingy, byte expression, and then getting the first half of that, and getting the second half, kind of extracting them, ripping them apart, only to then glue them back together. And that doesn't make any sense. So let's fix that. And that should simplify this one, and it should make it easier to later on optimize parameters as well. Okay, so I guess the first step to that, that's actually one of these obvious optimizations. Yeah, so in here, let's do, not entirely sure. Let's try to optimize the aggregates. Okay, so if there's only one part, then we don't need an aggregate. Fair enough. Here we have the parts. Optimize those. Yeah, I think we don't need to build a new list. And that's maybe even like yeah, let's separate this loop also into 2 different loops, just to make it a bit less complex, a bit less intermingled. So we have this, all parts optimized, and we push that to the parts. And then we do a second pass. That's going to be another list of Waffle expressions, where we basically we go over the parts in parts 1. Yeah. And if the part size is 0 and it's pure, then we don't need to put that part in there. Okay. So parts 2.push that part, and hang on. Yeah, let's do that. Oh, we've already done that now. Like, these parts are already optimized. We move parts. Remove 0-sized pure parts. Optimize parts individually. Remove 0-sized pure parts. Merge adjacent members of the same local. basically if we have something like at 0 to 8, and then we have at 0, 8, size 8, that becomes an aggregate of 0 dot 0 size 16. Yeah, something like that. So that's going to be parts 3. That again is a list of waffle expression. And yeah, for every part in parts 2, we basically do stuff. So the previous one is parts 3 dot last, maybe. Well, okay, let's first push that. Let's say parts 3 to push that part. But then let's also say if the part is, hang on, if the part dot kind is a member expression, yeah, that's some members part dot kind dot member or continue. If it's not a member, totally fine, you know, we'll just go on to the next part. And then if there's an ID inside, you know, like member.off dot kind, and that is a local, if that is both true, then we try to get the previous yeah, maybe parts 3.len minus 1 is the last one that we just added, minus 2 is the previous one. And then if the previous one is also a member, and it is also a member of a local thing, hang on, yeah, you know, if local equals, local should be previous local, or this optimization doesn't work. Yeah, you can see this all continue everywhere. This is, you know, quite a special casing optimization. So if they are expressions of the same local, and if, oh, hang on, member dot, let's actually do this so that they're kind of in the same order visually in the source code right here as they are in the struct. So then if the previous member dot offset plus the previous size, that should be the member offset. But if that's the case, then we actually merge them. So we do parts 3.pop, and again, and then we do parts 3.push a waffle expression of some kind. Well, waffle expression kind dot member of a waffle member of the local I'll just build a new one, I guess. Well, no. Let's just do member.off or something like that. Yeah. At the offset previous member.offset. but of a different size, of the previous size plus the current size. Oh, hang on, the previous size plus part. And the alignment is gonna be the, I'm actually not sure. The sum of alignments, the maximum alignment, yeah. Is that gonna make a difference? Could that make a difference? No. No, not really. Okay. Yeah, that is kind of crazy. Pretty crazy, actually. And then we do if parts 3.len is 1. I'll just return that one expression, otherwise an aggregate. Oh no. Okay, so previous is a maybe. Hang on. Oh yeah, I'll continue. To be honest, I kind of like this style of just, you know, writing down how you expect things to be, or they should be the same, that should be the same, and then just having these all continues afterwards. That's really not nice pattern. So this call doesn't work. Parts to slice. Yeah, because we want parts 3 to slice. Let's see. No, not quite. Hang on, we have an aggregate with a member. Why not? Oh no. I think I know why. Maybe not. Now that should work. Yeah, we build an aggregate of that, so that's weird. Member at 0, 0. Aggregate of member of local with previous member. This is with just with something previous. This is with a previous member of local. Let's see what this gets. Nice. Okay, we do have an aggregate of a member of a local with the previous member of the same local. That is true. But they should also have the same the previous member.offset, I think that we are here, you know, the previous member.offset is 0 plus the previous expression's size, which is 8. That should be the member.offset, the 8. Let's maybe print the previous member.offset. And the previous size, and also this member's offset. Okay. Oh. Previous member is also 8, 8. That is weird. That's really weird. Let's double check this. We have the member, that is the part, kind, member, or continue. Okay, then the local behind that is the member of kind dot local. Okay, the previous one is parts 3, maybe of parts 3 dot then minus 2. And the previous member is, nope, is previous dot kind dot member. Yeah, then the previous local is previous member dot of dot kind dot local. Then we check them. Okay, let's see if this works. Oh, oh, that is nice. That is nice. There's no longer a local, so an aggregate of members. No, we just have a single member of 0, 16. Hang on. That is the entire thing. Oh, I see. So we construct a member, but then we also want to optimize that. So if that is, another member, like a member of the entire thing, gets more and more beautiful. Okay, so this is really simple. That's nice. Okay, what else? I guess let's try to inline parameters using various. Hang on, let's commit that first. Yeah, let's see. So we have this, which is now called can copy, which is way more descriptive. Yeah, rename inline to can copy. Okay, we optimize more stuff, move adjacent. Yes. And then we do not just tree shaking, but also nesting locals with only one immediate usage. Hang on, in here, let me move that one. Does that fit on the same line? No, not quite. Okay. Nest with one immediate usage. Yeah. Now let's also add another very similar function for nesting parameters. Immediately used is so much more concise than with one immediate usage. Oh, that's only one usage. Nest params. Yeah, I don't know. Yeah, used is bool. Oh, hang on. I think we'll need to do some groundwork for that first. Tries to nest params. Yeah, if any stack stuff happens before the params are used, such as a push, then we cannot nest them. Directly in here. In that case, this function returns none. Yeah. So what we do is we do kind is expression of kind. If that is a param, no, not can't do that. If it is padding, then that doesn't work. If that is a byte, that doesn't work. If that is an int, that doesn't work. If that is a local, that doesn't work. Nope. And this is unreachable basically. I think. I think so. Yeah. If this is an aggregate, every part we do try to push nest params. With one immediate usage. Yeah, if that is not used, then if not used, then we also say no, doesn't work. It has to be used in the first part of the aggregate. Yeah. For the member, it has to again be used directly. If it's not been used yet, that's an error. Yeah, then we have the switch. Oh, where we take the byte. If it's not been used, that's an error. Then we have the switch. Cool. Shouldn't need that. Oh, because it needs the used thing. True. This needs the if not used. And that's an error. Okay, the call has these args. If it's not been used, then that's an error. Nice. Then call indirect as a function pointer. That has to be immediately used, otherwise that's an error. Oh, we have like half of that copied. Yeah, the args are just the call args. Nothing more to do there. Okay, the function pointer is immediately an error because it pushes something to the stack. Well, it's not the first expression, you know. An add is, well, yeah, that is that. Div mod compare 0 and or axle. Yeah, they don't immediately have that. And then malloc has, yeah, exactly, has that for the size. And yeah, it has to be used by them. The free nests param with one immediate usage. Exactly the same. Same with reload and with store. Yeah, for the crash. Like that. Okay. Yeah. Nest params with one immediate usage. And then we do, well, I guess that, yeah. And if params, oh, hang on, if num references dot get of id 0 is not 0, then we just return the original body. Otherwise, we iterate over the locals. Hang on, no, not, that doesn't work on any body, that just works on the entire fun. Yeah, that makes sense. And in here, the Waffle fun has a DAG and a body. So we don't need that. Yeah, and we do, hang on, number references. We go over the fun dot body dot locals. Yeah, we count the references in there and of the return value. And then we do num references dot get id 0 should be 0. Otherwise we want to inline the parameters. Yeah, actually in the Waffle, let's put the like this, nope, but in the body, and Waffle fun is a body. Yeah, I think the body should contain, the outermost body should contain the param as an explicit thing. Like when converting I don't know, something to Waffle. We have this DAG. Put the parameter in there, giving us an ID. Yeah, then rather than creating Waffle local for that, should just point to the actual like local that we've created there. And then we do body.toWaffle that does this. Oh, I see. I think we need to, yeah, okay. I think for the outermost body we then need to inline that here, which is a bit unfortunate, I guess. Yeah, that's that. The body is actually just the fun body. Sure. here mapping is already that, so we can remove that. Mm-hmm. Mapping is a map to, oh, not waffle expression. Hang on, what? Oh, I see. Yeah, okay, so this is supposed to be the param, like that, maybe. And then we put the tag into the param, giving us some ID. And the param, we actually put that into the function body. Hang on, no, not correct. We actually get an ID for that, I guess. Yeah. Waffle local. Takes an ID and then the size and alignment. Okay. Oh, but instead let's build it up local, I guess. Yeah. I'm really not sure about that. Yeah, okay, I think that's the right approach. Yeah. We have those, we create a body builder. And now we have kind of done that. We define a local reference to the param with that layout. Yeah, okay, that makes sense. Kind of. Let's see. Now the local is supposed to get a waffle expression. Really? Okay. So I guess we do need to do this only down here. Which is fine by me, to be honest. Like that. Let's actually split that up. Let's say we have first a map from pesto ID to ID. Oh, hang on, to waffle expression actually. And then down here we say mapping dot put find body param, put that param in there. Yeah. So when printing the waffle, we now actually need to handle this. And this just prints param. That's it. Yeah. Yeah, optimizing this is just not possible. So here we just return the original expression. Waffle expression kind dot param. And that's totally fine. Nest locals with one immediate usage. And nest we have nest locals with one immediate usage. Of body and dag. Yeah. And then we say get. Oh, we can even look at the previous one, at the unoptimized version. I think this is fine. Yeah. Rather than this, I should remove this from the printing. We now just have a local for the parameters. That's pretty cool. That.get local. Okay, so this fails. Here we have some sort of map from ID to int. Then not a map from ID to int, not. Why am I scrolling somewhere completely else? That's weird. Yeah, this is a map from ID to int. This probably fails. Yeah. Now nest. Nest params. And I'm looking for nest locals with one and this one. Yeah, this get only exists on the DAG. Okay, number references with previous. Okay, so the previous one is. Oh, I think this should just be get. Maybe. Or 0. Yeah, if an expression is referenced 0 times, that's totally fine. And then it's just not in the map. Yeah. Okay, so we are optimizing stuff. And the way we do that is, well, first of all, let's remove the printing this. Well, not that. Moving this. Yeah. So the first expression in this function should just be the parameter. It can be nested inside others as long as it's really the first leaf node, I guess. So this is fine, but this should be actually in there. So let's go into this nest thingy. And here we now check nest params with one usage. What is going on here? Yeah, this one. Nest params with one immediate usage. Done that. Okay. Nest params with one immediate usage. I think param is actually the correct. Before the param is used, that's the push. Yeah, then we kind of nested it. Yeah, I think that's fine. So we get the references. The DAG is just the fun DAG. Yeah, same here, just fun.dag. References get ID 0. If that is not 0, yeah, then we return the body. Hang on, num references, doesn't that also exist for count references? Count references, yeah, that does exist for, oh no, the body also needs to check the body returns. Yeah, but then in here we can, instead of this, yeah, we can just do body.count references. Nice. And the same down here. Down here. Yeah. Num references. Oh, fun.body. Sure. And fun.dag. Usual stuff. Num references get ID 0 is not 0. What? Yeah, this makes more sense, you know. Kind of. If that is not 1, okay, maybe 0 or 0 is not 1, then we return the body. Okay. No, hang on, then we just return the function, because there is nothing to optimize here. Otherwise, what we do is we try to do stuff. We have the locals in here, and we do used is false, param used, and we don't need to merge locals, I think. Actually, not sure. Let's go over the body dot locals, but not in the without the first. And we try to push that. Oh, hang on, we try to I don't even know, if param used dot if the param has not been used, if the param was already used, then that's totally fine. We just push the local and everything's good. Else, if the parameter has not yet been used, then we basically want to take the local kind of get the kind of update that. Yeah, somehow like this. Now we get the local dag.get fun dag.get local nest param with one immediate usage. And if it has not been used, then we'll just return the original fun. There is nothing to do for us here. Yeah, otherwise, basically do this. Oh, hang on. No, wait, that was different here. We did this. Yep. Push the local and then or if that doesn't work, then we just return the fun. Now that's it. Yeah, if param used, yeah, perfect. Let's see. DAG of an expression in 49. Yeah, body returns, that's that's already an expression, so we don't need that. Makes sense. Okay. Actually, you know what, let's... I think this is not even used yet. Which is fine, because I'm just realizing that we don't do anything about the return. Yeah, about the return value yet. Like, this should also be put in there. So nest locals with one immediate usage. Basically, we want to check that if yeah, body returns, okay, yeah. Basically, if locals dot last, maybe like that, and num references of num references of that is 1. Yeah, this one right here. Then we do this. No. If used, then we just pop the previous one. feels like duplication, kind of. I don't know. If used, then boom, this one. Then locals.pop, the default case evaluates to nothing. Previous cases to empty. Okay, I think we need to ignore that. That looks fine at least. Let's see if that changes anything. Oh no, that is a bit radical, I would say. No. Oh, I see. Yeah, because that return value needs to be used down there. Yeah. Now there was only one local, and then just a call and something that gets immediately returned. Actually, though, I think we can do even better. I think we can say that in the Waffle, the Waffle body doesn't even have a return value. Instead, it just has locals, and it just returns the last local. That would make sense. So a Waffle body only has locals. Let's think this through. Before doing anything rash. Okay. If I only have a function that returns a 2, now that's just a Waffle expression 2. If I turn that into a local, that would actually have an ID. But as long as that ID is never, like the last expression is never used. So I think that's actually fine. Yeah. Yeah, that does mean that in here I have to do quite a bit of rework, probably. Hang on, no, only in the body. Yeah. So for every ID in the expressions, we do that. A body builder of a DAG, that I'll adjust that. Is that like a fun finish? Yeah. I mean, it's that the builder is literally just it does have locals and alignment and so on, so I guess. Yeah, sure. So we finish this, but without a return expression. Just push that to the locals and that's it. Yeah, we don't need that. Instead, we just do builder dot local of that. So for the waffle switch, cases are waffle bodies. I mean, yeah, that is not. Can't check that right now, unless we also have the tag. That's true. Let's just not check that, I guess. Oh, but we do need this, definitely. I'm not sure about that. I am really not sure about that. Maybe. Could say that every body knows its return values, size, and alignment. Something like that. That would work, yeah. But it does seem like this does not seem as clean as I hoped. So I think I'm actually gonna leave that in, and then yeah. Pesto to waffle. Yeah, let's undo some of these changes like that. Undo. Yeah. Okay. Okay, yeah. This looks. Oh, look at that. The param got kind of inlined into the mul and into the add. And that is crazy. Nice. Hang on. I'm a bit suspicious because do we even I don't know, that does not seem right. Nest locals with one immediate usage, I think that's the one that also puts the param in there. But that's not quite correct. Like if we use the parameter in a different position than the first one, then that should not be inlined. For example, let's say we main accepts an A, so let's put the A in there, for example. This should not be inlined in here, the param. Nope, nope, this is not correct. Because param kind of implies, oh, this is already on the stack. We don't need to do anything for the param. Which doesn't work if we do stack stuff before that. So we actually need to, in the nest code, we need to check that the previous one, if that is a if dag.get previous but kind is param, then we also continue. We don't want to, try to use params, kind of inline them and nest them in anything else. Yeah, exactly. At least not in this general nest locals function. We do want to nest them in this specific nest param function, nest param with one immediate usage. Called on a fun. So we can do that here. Like that. That's just the fun body, true. This is the fun dag. Oh yeah, the return should be mapped, definitely. Basically, if the param has not been used, well, then we want to try to put that into the last one. We want to do this. New version is fun.get. Nope. That's just body.returns. Param used. If it's not been used up until here, then we also don't want to have anything. Then we just want to leave that at the beginning of the function. So we just return the original fun. 386. That is down. That's up here. Okay, nest param with one immediate use with a waffle expression. A mutable dag and params. And line 300. If it's not been used, then we just return an error. Okay, and here we try to assign, well, args. Oh yeah, we don't need to put them on the heap because we haven't been mapped them. Yeah. Same in the waffle store. Okay, 3A, now we're here. dot dag. I see. .396 returns is of course fun.body.returns. Yeah, this should use the new mapped returns thing. Okay, it is actually a waffle body true. So let's wrap that in waffle fun. Waffle fun has not just a body but also the tag. Oh yeah. Nice. Yes, please. Yes, and yes. Okay, so these get inlined, which is pretty amazing. Param basically says, well, this is already on the stack. Here, this is already on the stack. We only need to call add. That's it. Here, yeah, this is on the stack, but we kind of ignore that because we first push the 2 and then we reference that. But if we put that the other way around, then we should actually be able to inline that in here. Let's see if that works. So if we multiply a times 2, now we don't need to kind of ignore that what's on the stack and then push the 2 and then reference that again. Now we should just be able to have the param inline in there. Ooh, no, not quite. Let's param with one immediate usage. Yeah, and it has unreachable. Hang on, what? Oh, hang on, wait. How does that currently work, though? I mean, where do we return OK? You know, that's what I'm wondering. Let's param with one immediate usage. We have error, 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 error. And yeah, in the end, we return OK. I think in here we should actually do we do used? Where do we use used? Do we set that to true at some point? No, no we don't. Yeah, because I think that should happen in here, in the local. Actually first, let's, I'm kind of confused. How does it work for the others? How does it work for the add or the multiply function? Yeah, here we have param in there. That is weird. That is really, really weird. Let's look at the mod thing. Let's comment this out, see if that's, if they are still inlined. They are. Okay, so this is not correct. Not correct at all. They get inlined because of this somewhere here. Oh, I see. Hang on. In here, nest locals with one immediate use. We get the previous one. If that is a param, then we immediately abort. But we don't do the same here. This is so cursed. I don't know if I can kind of... I want to merge these two, kind of. Yeah, that looks better. Yeah, let's merge these. So we kind of need a previous one. We need to get the DAG. Given an expression and the DAG. Basically, we want to do that. So if dag.getPrevious.kind's param, then return false. Return error. Like that. And the previous is, well, yeah, we also need the number of references, which is a Or return error. Doesn't work. Then we have this used thing. We say the new version is dag.getLocal. I'll get the current one. Yeah, and nest locals with one immediate usage. Or if that doesn't work, then we just return an error that didn't work. Otherwise, we just return OK with the new version. Hang on, we can simplify that. Yeah, that already returns what we want. So we can just do that. Hang on. No, not quite. Just only if it's used. Why does that need a mutable tag? Does this do anything with the tag? Well, yeah, getting IDs, sure. Recursively calling itself, sure. Nope. Doesn't need to be mutable, so let's turn that into a read-only thing. Okay, yeah, and then here we can just do, well, dag.getLocal dot nest locals with one immediate use of the dag, the previous one, which is this one, nest locals with the expression. Oh, I see. So this also needs the dag and some sort of mapping. Oh, yeah, the number references. I see. And if that works, then you want to do something. So if this is some new version, then you want to do this. I don't know. I guess this is fine. Okay. let's maybe refactor the names here a bit. So when I have nest locals, I think that is fine. Yeah, nests. If a local is defined and then immediately used without an impure in between. Yeah, we nest move, yeah, the if a pure or unpure local is defined and then immediately used without an impure expression in between, remove the local occurrence, remove the local remove them. Boom. Nest locals. Very cool. Then this one right here, I'm gonna rename that as well. Maybe just try nest local, something like that. Then makes sense that that returns a result. So this then is just try nest local. I like that. Okay, this call doesn't work. Let's then look at this. We have the body returns thing. If returns dot try nest local locals dot last maybe, if that is okay. Oh, hang on, we can read even better. This doesn't need short circuiting, this could just literally return a maybe, which I think is a bit cleaner. Yeah, and then in here we can return a sum. Nest local, well, I don't try nest local, yeah. Instead of previous local, let's just call that local. Yeah, that doesn't conflict with that. Yeah, now things are a bit shorter, which is really nice. Look at that. That's cool. And trying as local, passing a local is also really good. That makes sense. You know, just makes sense. Could inline that. Could inline that. Could also not do that. I guess that's fine. Good. At least in the byte, we can do that. You know. Okay, so we have a switch, and then we do a switch.byte.try_nest local. And then if it hasn't been used until there, that's an error. Must have been used. That literally just checks if used. Then it returns okay. Else it returns error. But that means that we can now just do yeah, here we can just do must have been used. Boom. Which is pretty cool. Nice. Yes, please. Having a formatter would be really nice. Well. Clean. Yeah. returns, and then we just do returns.try_nest local. That's some new version. Then returns is the new version. And locals.pop. Don't ignore. Indeed. This is just nest locals. Yeah, this one. Enabled that code, so that makes sense. Try_nest local, this call doesn't work. This is the signature. Try_nest local waffle expression. Also needs the DAG and the num something. Num references. Sure. Okay, yeah, that is expected. And now let's do this. Nest param with one immediate usage. Okay, that panics during optimization. Well, nest param. Yeah, I'm gonna call this like try nest param. That doesn't need immutable DAG, does it? Only passes it on. Does it need the DAG at all? We have a function. I think it doesn't need the DAG. Nice. Yeah. So this is, I'm just going to replace all of these. Used dot must have been used, question mark. True, that is now called nest param in mod, yeah. Oh yeah, true. It is called nest param. Yeah, and in here that is just, yeah, I think here nest param is fine. If that doesn't happen, then it doesn't happen. So these, I'm gonna unify these. So the common thing is that tries term should return a maybe waffle expression. Yeah, and it basically does Is there a difference between not using the parameter and kind of well, using the parameter versus, like, if there is an impure thing or something that uses the stack, then we can't use the parameter. But if we just, if there was some expression that does something, I don't know what, but doesn't touch this, oh, that doesn't exist, yeah. Yeah, I guess. Let's just say that this just returns a maybe, that's fine. And what we do is we have an expression. What do we have in the other case, in this one? We just have the previous, which we don't need, I think. No. They have a DAG and num references. Yeah, we've already checked the references here, so I think we can just do no, let's not do that. Let's do that directly in here. Okay, so we're pushing the local. If the param is not used, and then the new version is going to be trying as param, correct, of the function DAG. Or if you can't nest that in there, then we'll just abort everything and return the original function. Perfect. Otherwise, we say, hey, function DAG, please set the new version. And we don't need to do that. And then we do returns as fun body returns. And if the parameter has not been used, then we do returns equals this. Returns.try as param, or we return the function. And if the param then still hasn't been used, then we just abort. Perfect. So the param has to be used somewhere in the function. Okay, that seems reasonable, I think. doesn't work. Okay, try nest param. Oh yeah, I think if the ID, yeah, if we see an ID somewhere here, local ID, that's not unreachable. I know, we just have to check, you know, if the ID equals 0, then that's actually a param. Then it's waffle expression kind of param, and we'll actually set used to true. Otherwise, we say, nope, this can't be used, because we can't just push another local ID there. Yep. Oh, haha. So we have the multiplication works now. We have multiplication of the parameters. Addition also just uses the parameters that are on the stack. The main function can't do that because the parameter is supposed to be the second argument to the multiply function, not the first one. So we say, okay, well, the parameters, they are on the stack, sure. And then we'll actually call the plus function with an aggregate, with a multiply function, with something. And then here we push those parameters to the stack again. But now, hopefully, if we change that, if we switch that around, if we say a is the first argument to the multiply function, then oh, we still have a local. Would have hoped that the param was just in there, because then we could just, you know, basically push a 2 to the stack and then call the multiply function without even touching the arguments that we were given. Although that doesn't work for some reason. That's sad. Let's see. So we have some sort of call. Yeah. Let's start from here, I guess. So we say nest the param, please. The number of references is 1. There's 1 reference to the 0. This one. Yeah. So, yeah, the reference count is 1 of that. Well, not reference count, the, yeah. Okay, so we built the locals. Param used as false. And then for all the locals in this function body without the first one, so without this one, okay, starting here, we push that. So, oh, hang on, that is not a local. No, that is not a local, that is a return value. Okay, so there is actually no local here. Fair enough. So then we look at the return value. And that parameter has not been used yet. So what we do is we do try nest param. Here's the function tag. The returns expression is this one right here. So try nest params. That calls this one with this expression, so that is a call. So we should try to nest the parameters, call ourselves recursively, which is an aggregate, which is here. So we build parts, and then for every part in the aggregate we just check try to nest them, please. So the first part is this one, try nest param. That's a call again, so we go here and we try to nest the params in this aggregate that is here. We try to nest the params in the individual args. So first in this one, now that is a local with the ID being 0. So we should just set used to true, because now we've used the parameter, we want to insert the parameter here and just evaluate to waffle expression kind.param. And then down here we say, okay, we'll return and we use the parameter. Then in the surrounding aggregate, we should say that used must have been used, and that has been set to true up here. So then we go to the second part, this int. Oh, I see. Okay, so padding is allowed after we have used the parameter. So actually, just want that, and then some waffle expression kind dot padding of that same command. And same here. That makes sense. Okay. Here as well. Oh, look at that. Sweet, sweet, concise code. Beautiful. Clean. Okay, this is nice. This is really nice. So now, because param is the parameter is the first argument to the first function here that is called, we just use that directly, and we just push a 2, and then we call that function. We push a 4, and then we call that one. That is nice. That is really, really nice. Wow. That's crazy. That is crazy. So let's turn that into bytecode, I guess, into ground. And just to double check, like if I switch this around, then we kind of need to keep around the argument on the stack, and we can't just immediately use that, right? That's nice. That's just very nice. Okay, yeah, I guess waffle to ground. Waffle to ground, that fails probably because, yeah, parameters are now a thing that you have to deal with. Actually, parameters is just, it can appear a single time in the function. and it can only appear before any int, byte, whatever expression, and we don't need to do anything there. Because the param expression is just a marker, you know. Hey, the params are supposed to be inserted here, and they are already on the stack. What? Okay, so the bytecode is now going to be amazingly small. Yeah, okay, we don't print the bytecode. Well, let's do that. Let's print it. I think my T is empty. Oh, sad. Look at those. Look at that tiny program. Before. What? That is nice. So let's see. We have a program that takes a number and then it multiplies 2 and that number, and then adds 4 to the result. And they look like this in some of the intermediate stages. Well, let's get the argument out of the argument struct and then create a 2 and then put them into a struct and then call them, I don't know what. Now that is efficient bytecode. We push a 2 to the stack. Okay, that is not quite correct. Because that pushes the 2 again to the stack. Why is that happening now? Just when I'm thinking like, wow, that's genius, you know? Nope. Okay, but we call the multiply function. Oh, I see, which literally just multiplies stuff. But then it shouldn't pop the elements below the top, because and that's probably also here, like, hang on, in the function, the body, compile expression, compile body. Yeah, we have the size of all the locals. That makes sense. Yeah. Now the stack contains the params. We compile the body, and the body, the outermost body contains a params expression, and it takes care of freeing the params. So this, we don't need to do this anymore. We don't need to free the parameter, because the parameter now is guaranteed to appear somewhere in some body, and thereby it's automatically freed. The code gets smaller and smaller. Hang on, only 9 is, that was some more before. Should do less printing, I guess. Well, okay. Anyways, we push it 2. We do this with the wrong thingy, but I guess okay. Then we call instruction number 6, which literally just multiplies them and returns. Nice. And then we push a 4 to the stack, and we call instruction number 8, which literally just adds the numbers and returns. And then we return here, ending the program. Oh, that is cool. That is so cool. Okay. Wow. Honestly, wow. That is nice. Push 8 from stack. That is kind of confusing to me. So let's see. We have initially we say the parameters are on the stack. parameters are on the stack at position 0. Oh, I see. And the stack size is the size of the parameters. That makes sense. But then when we compile the body, we say, well, this is the expression. We align the stack. Okay. We add a mapping. Wrong. We only add a mapping if this is not the params expression. So if local is not i0, the parameters, they already have their own mapping, and the params thingy here is just a marker that they are already there. We don't do anything with that. Hang on. Alternatively, I think that's actually the better thing, be to just do that all the time. But not have the initial mapping for parameters here. Don't do this, don't do that. Oh yeah, okay, we need that, so I guess from ID to int or something like that. Yeah, maybe that works. Oh yeah, that works too, I guess. But okay, no, that does not work. Interesting. I was assuming that we have the something of a function ground builder. Let's see. So we align the stack, we add a mapping to 0, we compile the expression, compile switches on the expression kind, and then does stuff. And it also does builder.push8. I think that is the ground. Is that defined up here? I think so. Builder.push8. Yeah. Oh, I see. And this adjusts the stack size. And now we also have param. It does nothing to the instruction. It only adjusts the stack size. Nice. I mean, you know, let's inline that. Yeah, I think that makes sense. Oh, plus expression of size. Okay. Yeah. That is cool, honestly. Ooh, what's going on there? It may actually be correct, though. So we push a 2 to the stack. Oh yeah. Then, from offset 8, skipping the 2, we push the original argument. So now we have the argument on the stack, then the 2, and then the argument again. Then the multiplication kind of combines the 2 and the argument. So now we have the original argument and the result. Then we push the 4 as the third integer on the stack. Then we call the addition, which merges those two, but then we still have the original argument and the result on the stack. So we need to pop the argument below the result. That is cool. That is really cool. Let me try something kind of crazy. Let's say, like the fact that we use the stack so effectively now, I really like that. Let's say I have some point that contains an x and a y. Maybe that's like point 2D. We also have a point 3D that contains an int. And we have a make 3D that takes a point, which is a point 2D, and returns a point 3D. Whoops. Here, for example, we would just say point dot, well, we want to return point dot x, y is point dot y, and z is 0. And then here we say we have a point, you know, that is maybe x is 1, y is 2, and then we say make 3D of that point. And then we, I don't know, return a dot y, something. No. Oh yeah, this is 2 is not allowed, I think. Oh. So point plain, point volume, maybe make volume. Reference, oh yeah, make volume. True. I should add a make file so that I don't have to compile the compiler every time, even if nothing changed. See that there is call 7. 7 is the make point 3D. Just literally pushes a 0 and then return. That is nice. It feels like, you know, these functions, they are elegant. They know how to reuse the stack. They know how to handle the stack. That is clean. Just push a 0. I mean, we do all these, you know, like struct access stuff in here, and all of that just collapses together. That is crazy. That is honestly crazy. Oh man. Okay, so what happens here? We push a 1 and a 2, okay, and then basically we push this one, 3, a 0, yeah, then we pop the 0. We pop below the top the 1. Oh yeah, and then we also pop the argument that was given to the main function, so that only 2 or something remains. Oh, that is nice. That is nice. Okay, I think I'm gonna end it there for today. I've still trying to get over how cool that is. Okay, yeah, let's commit stuff. So, first of all, yeah, this got kind of cleaned up. Clean up nesting code. Nesting and nest param. Nice. Oh yeah, this is also true. Yeah. Can I pesto to waffle? Yeah, let's amend that. Git add compiler pesto to waffle. Yeah, and then git commit amend nesting. Boom. Okay. then that is just, I mean, yeah, I guess. Allow body, no. That is clean up printing. Waffle, then we have this, compile waffle to ground. That was, like, this is surprisingly clean. I mean, hang on, let's even, yeah, let's turn that into one line. But like in general, I think changing that has removed more lines than it has added one. And this, like, this is way simpler now. What? This is such an indicator of design that just fits together. That's, you know, nice abstractions, that everything becomes simple once you have that. And it took some time, you know, figuring out that, like, just I spent a lot of time working on the compiler stages, but not a lot of time figuring out abstractions for optimizations. And I'm happy that I did that. You know, initially I was like, hey, let's, you know, first do, you know, figure out the language before attempting any optimizations. But I think it's important to get those, the kind of the software architecture for those optimizations right up front. Because in this case, for example, adding those optimizations not only made it way easier to debug the Plum code, it also kind of improved some of the abstractions and how I represented those compiler stages to make that more natural. So I think, yeah, that was a really good idea. A really good idea. I'm focusing on that first. Okay, yeah. In the future, like, what's up next? You know, I'm not entirely sure. I guess maybe some small language features. I have some that I want to do anyways. Yeah, my voice is giving out. I spent too much time talking today. But I think we're on a good track, and I like how things slowly begin to fit together. The code becomes cleaner. The generated bytecode is really elegant, and the compiler kind of feels smart now. You're just writing a function that takes a point and it creates a new point with that same x and y but a different z, and the bytecode for that is just pushes over to the stack. That's nice, you know. The compiler feels like it's actually doing something. So I like that. Yeah, I guess I'll think about where I go from here, and for today, that's it. See you next time.